Alright, so this video is to help you remember how to do the factoring. On your original equations, you got to remember hk. So you have a divided by x minus h plus k. To do your horizontal asymptote, it's the opposite of h. Excuse me, your vertical asymptote is the opposite of h. Your horizontal asymptote is the opposite, or is exactly as k. So with that, this one would be h equals 1, k equals 3, so x equals 1, y equals 3. Those would be your asymptotes. And then based on that, your domain and range. So quickly, I am not going to graph these ones out, but I will explain how to get your asymptotes. So your degree on top is 3. Your degree on the bottom is 1. So since the degree on top is greater by 2, we have no horizontal asymptote. So no y asymptote, meaning no obliques, no y equals 3s, no nothing. So it's just a horizontal one, or not horizontal one, excuse me, a vertical one. To get your vertical one, you take your denominator, set it equal to 0. So 2x plus 2 equals 0. 2x equals negative 2. X equals negative 1. So based on this, your domain is all real numbers. X cannot equal negative 1. Your range is all real numbers. You will not have any indication of any changes of these values because there is no y or horizontal asymptote or break in the numbers when you graph this. It's just all real numbers. Now when you plot these, make sure that you use a value or a color code, whatever you want to do for the colors, and clearly let me know where those asymptotes are. Okay. On 8, you have a degree of 2 on the bottom and a degree of 1 on the top. So with this one, you have degree of 1 divided by degree of 2. The degree on the bottom is heavier, so it is y equals 0 for your horizontal asymptote. To get the bottom or your vertical asymptote, you must factor. You get x minus 1 and x minus 3 over x minus 1. So right now x cannot equal 1 or 3, but because the x minus 1 is going to cancel out, this becomes a point of discontinuity, which is not an asymptote anymore. So when you state it, your only asymptote is at y equals 0 and x equal to 3 are your asymptotes, but if you want, you can say x equals 1 is a point of discontinuity. Now, when you do that, what happens is when you do your domain and range, it's going to be off the values of this function here because that's your simplified version. So your domain is all real numbers except x still cannot equal 1 or 3. Your range is all real numbers. Y cannot equal 0, but this point of discontinuity means there's a hole. Okay? When I plug this 1 into this equation, I get 1 over 1 minus 3, which equals 1 over negative 2, which means this y value also cannot equal negative 1/2, which also tells me where my hole is going to be. So, asymptotes. You have an asymptote at 3, and then you also will have an asymptote at 0, but this whole value of negative 1, so at 1 negative half, there's a hole, and so you have to account for that as well. Now, when you have values that cancel out top and bottom again, and you're left with some other stuff, let's look at that. So on this one, the top cancels to, or factors down to x minus 1, x minus 1 plus 1. The bottom cancel or factors to the same things. Okay, so x equals 1 and try that as a negative. 3. With those canceling out, my degree on the top is 1 and 1, so the leading coefficients are 1 divided by 1, so y equals 1. And then I also have this guy that becomes the point of discontinuity, or your whole, because it canceled out. So my pretty fraction is x plus 1 over x minus 3. That's what you can graph to get your values. Your domain is all real numbers. X does not equal 1 or 3. Your range is all real numbers. Y does not equal 1. And that comes from the asymptote. Now when I plug in this value here of point of discontinuity, 1 plus 1 over 1 minus 3 gives you 2 over negative 2, which equals negative 1. So also y cannot equal negative 1. So asymptotes. You have one at 1. You have one at 3. And then you have this point of discontinuity at 1, negative 1. So 1, negative 1 is right here, and that's your whole. You do the same thing on this one here, but with this, your denominators cancel out. So you have x minus 4 and x minus 5 on the bottom. On top, you have an x minus 4, x plus 4, and an x minus 5. So technically, your x's cannot equal four and 5. You have a degree, but since there's nothing left over when you cancel things out, there is no oblique because your line that's an oblique becomes the line of the equation. So y does not have an asymptote. Okay, and since these cancel, you have holes at these, which is your points of discontinuity. So there are no asymptotes at all, but your domain is still going to be all real numbers. X cannot equal 4 or 5. Range is all real numbers except y cannot equal. Now, when you simplify this, the equation of y equals x plus 4 is the only one you graph. So to quickly get your holes, plug this in. Y equals 4 plus 4. I get 8. When I plug in 5, I get 9. So on my graph, I would have holes. In order to do that on this graph, I would change your scales to be by 2. So if I go by 2s, 2, 4, 2, 4, 6, 8. So that would be my first hole. Okay, that's going to be the orange one. Then I'll get out a different color here for blue so you guys can see this. Go over 5 and then up 9, I have a hole right here as well. And then my graph would go through that.